Hello, I'm Stephen, this is Mick, and today we're going to be talking about algorithms. Before we begin, we just want to say that this is only a discussion. There are no right or wrong answers. These are just our thoughts and opinions which can and will change. Neither of us are experts on anything. We are just two dudes talking. Algorithms today, Mick. So I want to start this off by reading a couple of definitions of what an algorithm actually is, and then we'll continue it from there. So I've got here a technical definition that I got from Wikipedia, which says, and again, we allow Wikipedia on this podcast, although some schools, and I feel sorry for students, it's not allowed to be used on tests, reports, whatever, but it's good enough for us, I think. So in mathematics and computer science, an algorithm is a finite sequence of well-defined instructions, typically used to solve a class of specific problems or to perform a computation. Algorithms are used as specifications for performing calculations and data processing. Even for me, there's a lot of big words there. It's a bit of a complex definition. So the more general definition, and the one I prefer, is algorithms are a step-by-step procedure for solving a problem or accomplishing some end. All right, so they're two technical definitions, or two definitions from other sources. But for ourselves, Mick, what do we think of when someone says algorithm, or we think of an algorithm? So I'll throw it over to you. What comes to mind when people say, what is an algorithm?
Yeah, so first thing is, I think, a series of steps to get to an end mean. So whatever the outcome, I guess, is. But I kind of think of it as like describing a pattern. So if I was to, I think the advantage of an algorithm is you basically strip it down to it. You try to strip it down to an efficient process in order to get an end outcome that saves you some level of energy. So that might be computational, that might be, well, maybe not always. So I can imagine cooking. I think we'll sort of talking about this before, is cooking basically, if you follow a recipe, that's really like an algorithm. You basically put in these ingredients and you get this meal as an outcome. So I guess when I say a pattern, describing a pattern, I'm meaning that each time you follow these series of instructions, you get this outcome. So that must be a pattern, because otherwise it would break. If it wasn't a pattern, I give you the series of instructions, your outcome would be completely different to mine, and therefore that series of steps don't follow a pattern to get a desired outcome. So, but I think of pattern, and then I think of you generally use it to save energy. I don't know about the cooking one. Maybe that's just to gain pleasure. Maybe there is something to save energy if you having to find out yourself how well something tastes by following someone else's algorithm that has sort of embedded in it some really good rationale why decisions are being made, but you might not necessarily know why they're being made. So, the classic salts and fats and all the rest of it. What is it? Salt, sugar, fat, and there's one other, I think. If you carefully mix these together, you generally get a desired taste. And so a recipe can have that in there, and you might not be aware of the balance that they're actually presenting in that algorithm. You're just following the steps to get a desired outcome.
There's definitely an energy saving element to what an algorithm is doing, because like you said, you're offloading that having to think about every time, okay, what are the key things I'm trying to hit? You're just relying on the process and expecting a certain outcome. Like you said, that's the pattern. You don't have to consider, okay, am I getting all the necessary nutrients? What are the necessary nutrients? You don't have to keep going down that rabbit hole. It's just like, okay, follow this pattern. It's going to give me the outcome of a healthy meal that will sustain and nourish me, as an example.
It's true.
You said there, an efficient process. Now, this is to me an ideal, but it doesn't necessarily have to be efficient. I mean, we're both, as a bit of a background, we both have experience with code. We've both seen code that does what it needs to do, but it's far from efficient. So an algorithm, and we'll get to how it relates to code because that's another thing I want to discuss, but an algorithm doesn't necessarily have to be efficient. Ideally, it would only be the necessary steps to get the desired outcome. again, that goes to energy saving, but it could be inefficient. There could be unnecessary steps there. It could be doing things in a way that still gets the outcome, but you're doing a whole bunch of things that is unnecessary, is taking more energy, is inefficient.
Yeah, I'd agree. The goal is to make it efficient. Well, actually, I think there's probably two goals. It's to make it efficient and easily readable, accessible. So sometimes they conflict with each other. To make something a bit more readable might be less efficient. You can make something more efficient but less readable. So one goal is the efficiency, and that's an individual goal. But then the readability or the accessibility of your algorithm for others to use is a wider goal, I guess. It's a goal outside yourself. So if I'm to give you a recipe, let's say I was to give you a recipe in the kitchen, and let's say I wrote a pinch of salt. What's a pinch of salt? Now, I'm giving an example here that might not necessarily lead to efficiency, but I'm suggesting that if you cut in your description of what things are in order to gain efficiency, you can lose information. And so I think there's a careful balance in algorithms in providing enough information that other people can read it, but also to try and make it as efficient as possible.
It depends how you're defining efficiency. We can think of it as the minimum number of steps to do something. But like you said, if those steps if you have to put more energy into each of those steps in order to get the outcome, that isn't necessarily as efficient. Say you have 5 steps, but it takes you 100 units of energy to follow those 5 steps. Whereas if you put 10 steps, but it only takes you 90 units of energy to follow those steps, that's actually more efficient from an energy perspective. Whereas maybe from a number of steps perspective, it's more. So it really depends what you're trying to optimize for. It's like, do you want a accessible, understandable process that results in the outcome, or do you want a process with the minimum, most condensed amount of information that may actually take someone a bit more energy and time in understanding and being able to implement it in order to get the outcome?
Yeah, well, that's right. I guess it's where are you applying this algorithm and what's its end need, I guess. But I think it's still, there's two sort of competing factors, I feel. Whether you call that efficiency or performance or whatever you want to call it, if I only need to read an algorithm, I might be able to shortcut a lot of things and write it very quickly, and I understand it because I was the one that put it together, I guess. But then to convey that to you, I might need to use general terms or well-known definitions. And so therefore, I might need to add some extra elements to that algorithm that might make it a little bit slower, but at least you now also understand my algorithm. So I guess it's really where you're going to apply it and who's going to use it. And then you've got these competing trade-offs, I think. The more accessible you want it to come, I would say generally, depending where you describe efficiency, but if you're just looking at the system and it's whatever the algorithm is itself, the performance of the algorithm generally is going to decrease as you try to make it more accessible to others, I feel.
I got to think that one through, but that's all right. Getting back to how we define algorithms, for me, it is really just, okay, here's a series of instructions. Follow that, and a series of instructions that is pointing to a desired outcome. So as long as you follow those, you will hopefully, like you said, it's a pattern. You're assuming that if you do these things, it results in a desired outcome. In order to assume you'll get the outcome that the algorithm is aimed towards, we need to actually base the algorithm in something that is fixed, unchanging. And so what I'm saying is the algorithms themselves are usually based off of logic or reality, things that are fixed in our world that we know that, okay, if we compare these things in the same way every single time, it's going to give a certain outcome. And so we can rely on it. We're looking for things that are reliable, and then we build a set of instructions based off of those things that we can rely on, that we know with high confidence, again, nothing is certain, with high confidence that it will result in this outcome. Yeah, anything to say to that?
So just so we're on the same page, would that mean that if I put a known quantity in the system, I should be able to determine its outcome?
Yes.
Okay.
Yeah. So, and this gets to where we were talking about before the show, and when we were like, okay, let's actually record it because this might get nice and interesting. For any algorithm, like I said, it's based off of things that are, it's based off of logic, which is repeatable, which is consistent, which means that if you understand the rules if you understand each step of the algorithm, if you understand the inputs of the algorithm, if you understand the initial state and all that, you can predict the output, or not even predict, you can calculate the output. So I'm saying here that any algorithm, if it is aligned with reality, if it is aligned with logic, will give you a specific output that you can work out ahead of time. Now, where you have a problem with this is maybe you can go into this. So actually, I think we're jumping ahead a little bit too much.
Yeah.
Let's bring it back a bit. I want to talk about algorithms and computer programming. Do you see, for me, I don't know if there is or what the difference would be between like a function, a method in programming, and an algorithm, because a function basically is, okay, here's a bunch of inputs, do some processing and give me the output. Isn't that just what an algorithm is?
Correct. Yep.
Yeah. So then are we saying that there is really effectively no difference between a computer function, a computer method, and an algorithm?
Yeah, a computer functional method is a form of an algorithm written in a particular language that gets run on a computer. So basically, it's a algorithm which a computer can execute. That's what I would say. Yeah.
Yeah, it's still just a sequence of steps. Maybe as a more practical, let's give an example of an algorithm, and then that will help us hopefully and help others hopefully understand where we're coming from. So I'm thinking like just a basic sorting algorithm, right? You've got a list or an array of numbers. There are random numbers, and you want to sort them based from lowest to highest. So the goal then is to, okay, come up with a algorithm, a pattern, a series of steps that you can follow that will organize this list. And again, you're rooting it in logic because you need to make sure that each step that you do will result in the same outcome every single time. So one way to do this, and there's many different sorting algorithms out there, one way to do this would be, okay, let's start at the first element in the list, or the second element actually, and then we look, okay, is the number before it lower than this number? If so, okay, move on to the next one because it's already sorted at that point. It means the first number is lower, the second number is higher, then you move on to the next one. Okay, is the third element in the list, is the second element lower or higher? If it's higher, okay, we'll move that to the next one and then do the same thing again, compare it to the number before, and then you go throughout the entire list, and then at the end of it, you've got a sorted list. So is that...
That makes sense. So yeah, to simplify it is basically to go through each element and find whether it's lower than every other. If it is, put it at the top of the list. If it's not, whatever was lower, keep track of that and then put that at the top of the list. So basically each time you're going through the list, you're finding the lowest value, putting it in a new list, and just keep going through until you got an ordered list of lowest to highest, basically.
Yeah. So that's just an example of, okay, the algorithm is a series of steps that you follow, and then at the end you get the output, which is a sorted list. So that's like a very basic idea of what an algorithm is. But it doesn't have to be mathematical even. It could be, and again, we often think that algorithms, we're thinking computers, we're thinking programming, but that's not what it is. Again, it's just a series of steps that are aimed at achieving some outcome. So it could be, like you said, cooking, following a recipe. It could be something like brushing your teeth. Okay, you've got an algorithm to do that yourself. You've got an algorithm where it's like, okay, grab the toothbrush, wash it, put toothpaste on it, brush, and now what's interesting is when you get to the brushing part, okay, maybe you've got another algorithm there. How do you brush? Maybe you're a very organized person. You want to, separate sections of your mouth and make sure you give them the same amount of time. Maybe you just do it randomly. So it's like we can look at things in terms of systems. We can also look at things in terms of algorithms and algorithms contained in algorithms. Like whatever level you want to break it down to, it's possible to do that.
Yeah, that makes sense. I mean, I was just thinking as you're going through the toothbrushing exercise, that's what parents are teaching their kids. There's certain algorithms to get a desired outcome for that kid. So, okay, pass the knowledge down. If you do this, your teeth are going to be good, or make sure you brush your hair this way to get the outcome that you want. So I guess even as humans, when we're teaching kids or teaching other people, all the rest of it, often we're describing a process which is basically just an algorithm for that human then to, if I think about it in computer terms, you give the algorithm to the human so the human can go and execute that and get their desired outcome as well. So, yeah.
And then the next point on from that is we can have algorithms that actually update. So say you're brushing your teeth and you have a certain process or procedure. I'm using these terms interchangeably: process, procedure, algorithm. You're following a certain process and then you realize, oh, hang on, if I swap something around, it'll actually be better for me. So at that point, you actually update your process, you update your algorithm, which goes back to what you were saying at the start, which is that algorithms, we ideally want to make them as efficient as possible or as optimized as possible. So that's one other thing I want to get that. And when we talk about a little bit more about different algorithms that are more common, like, for example, a YouTube algorithm that's choosing what video to watch next, there's also a feedback mechanism that says, okay, let's update this algorithm. Let's change it. It gave us the desired result, but or it didn't give us the desired result, so we need to update something.
Yeah, so like I think if I go back to cleaning your teeth, if my teeth were all white on one side, but then there was one side that was getting a bit more yellow on there or something like that, then I guess the feedback is, okay, something's wrong on this part. How do I change that algorithm to get the desired outcome where all my teeth are white? And so the system gets some feedback, which is yourself that's executing it. My teeth aren't to where it needs to be. They're almost there. What do I need to do in order to get all my teeth to be clean? You go through your original algorithm, update, I'm not brushing enough on this side, so you'd update that. And then you would apply the algorithm and you say, okay, that's the desired outcome. So, yeah, so I guess an algorithm that gets fed back information to itself is an algorithm that updates. So there's algorithms which you just follow. I guess they're like static in nature, an open system where you just follow and it never gets feedback. So the algorithm stays cemented in time. So maybe that's grandma's, famous lasagna or soup or something where no one's really changed it. The recipe's what people want it to be and you leave it alone. But then there's algorithms that if you want to have some kind of self-improvement, you need to give some kind of information back to it to update, or you update it, one of the two. But you update it because of certain information from the outcome.
So the sorting one would be more of a fixed one because it does what you need it to do. You've already thought through, okay, what's the best way to do this? And you've programmed it like that. There's not going to be much feedback. But like you said, maybe there's a recipe that you're following and it's like, someone said that was a bit too salty, so now I'll go back and update that. I'll take out the pinch of salt and I'll just leave it as is. I want to go through actually, I was watching a video or a podcast and someone asked the other person, can you explain like how a YouTube algorithm would work, how it would recommend a video to you? And the guy didn't really answer it in, I thought, a satisfactory way. So I want to ask you, because I've thought through this myself, but I want to ask you, I know you don't work for Google, you don't know how it works in the background, but just as a kind of an idea and trying to give others an idea about how these things could work, because you can look at how something works and assume, okay, this is probably what they're doing in the background, especially if you've got a bit of understanding about programming languages and like loops and functions and condition statements, like how that would work, the types of ways that you could achieve these things. So I want to ask you, Mick, can you try and explain to us from your perspective or how you would actually do this? what would you do? How would you create an algorithm to recommend you a video?
Good question. So I guess I was thinking about, as you were talking through that, I think for nearly most algorithms, maybe there's a few exceptions to this, but most algorithms take an input of some sort. So, you got your cooking recipe, it's taking the input and the ingredients. You've got that sorting algorithm, it's taking an input of an unsorted list, et cetera, et cetera. So in this case, I think YouTube probably takes two inputs in. One is, particularly if you're new or you don't use the platform a lot, one is probably trying to describe you as a demographic. So you're male, you're this age, et cetera, et cetera. You live in this country, in this state, suburb, whatever. And so based on sort of population statistical analysis, it will put me in a category. And then based on my use, and I guess these are going to be weighted, meaning that one might be more valuable data set than the other. If I don't use it much, then there's not much valuable data there. But if I use it a lot, there's a valuable data. So, it's going to look at my prior history, really. So it's going to, I think it takes, if I'm just thinking off the cuff, if I was to make a YouTube algorithm, a rudimental one, it would be taking your demographics, taking your history, based on the level of history I have, weight them, and then do a calculation to figure out a video that you're likely to be able to likely want to watch. And then as you and then the feedback to the system would be, so they're the two inputs. It does its algorithm, and it would be a closed algorithm. And so what it would do is each decision it made, it would follow through to the end to see whether you went with that decision and how long you watched that video or et cetera, or whether you didn't go with the decision. And so therefore it's going to start to close out the error. So it's going to go, I guessed that he would like this, but he didn't really like it. All right, we'll take those kind of videos out because it doesn't seem like he's liking it. Or maybe there's a sample set, there's 5 of them. But then you put a video in and go, I actually watched half of that. I wonder if I give him more of those videos, will he watch more? So he watches, you give him more videos, he's watching more. So now you're starting to skew it to those kind of videos. But if I present you more of the same videos and while you had a peak period, it started to fall off, then that would be a category I wouldn't probably suggest to you. So that's probably maybe a very simple rudimental way that I would think about how YouTube would suggest videos anyway.
All right, I'm going to ask you a different question because I wanted more of a technical. Okay, if I type in a search term, how are you going to figure out what to show me?
Oh, so keywords, you mean?
Yeah, so video could be just any general search term. How are you going to figure out what results to present me? Say we both go on to a website, a video sharing website. I don't want to use YouTube here because I don't want to say their name too much. If we go onto a video website, we both type in the same term, we type in algorithm, but we get 2 different result lists. Why might that be? What steps do you think is going on in the background that's saying, okay, select these ones to show to Mick, select these ones to show to Stephen, even though they both gave us the exact same search term?
I don't think it would be dissimilar. I still think that the demographic and your history will determine which videos about algorithms it should show you. So maybe let's say maybe you watch this person, you subscribe to this person, or you watch this person's podcast a lot. And there might be a more popular algorithm video, but they might suggest the person that you're familiar with. So that's based on your prior history. It's a person that you subscribe to, or it's a person which you have been watching a lot of. And so while the category or the key term is algorithm, they're looking at anyone that's presenting information about algorithm that you might be familiar with, who you might be comfortable with. Let's say I'd had no history about you, but you're male, 30 years old or whatever, then it's going to go, okay, most males 30 years old like these kind of people. So therefore, I'm going to find an algorithm that's within this area. So it's almost like, I don't want to get too complex because you want it to be accessible to others, but there's a tree, so, a lot of people understand what a tree is in a searching algorithm and things like that. So you got a tree and there's a whole lot of branches. And at the end of those branches, let's say, is where you want to go. And I guess so there's a lot of different paths where you can actually go. And I guess because algorithms, a lot of people could actually do a video on algorithms. So how do I choose one for you? I have to choose it based on some kind of categorization of you. And so I would say that category is made from your history and your demographics.
Yeah, that's. I wanted more of a step by step. So what I would do is, for example, say that okay, you search algorithms, right? So it's gonna look in its database of videos. Okay, look at videos that have this as part of like a search term. Either someone else has put it in or that it's been tagged as a video relating to algorithm, right? And then from that, you've got a list of different videos. Now, how do I sort that list to present to you? Maybe you look at serve them the most popular ones, right? So at that point, you've just given them most popular. Maybe you want most recent. But if you want to get more specific to the person, like you said, you get in information about the actual user itself and say, oh, okay, they prefer videos that are more colorful, for example. So it scrubs through the video and says, okay, this uses a lot of varieties of colors. This is more likely to appeal to this type of person. So I wanted a more like technical, okay, in the back end, what's going on? And then how is it filtering down from a big list to a smaller list to ones that it thinks you will enjoy? Because I don't know, I kind of wanted to get to the point to highlight that there's a million different ways you could serve up someone a list of videos, and the algorithm again is just following a series of steps, a series of instructions about how to get to that point. What's important though is that who is telling it what those steps are? Where is it getting that information that these are the steps that you should follow to serve up that video? And that to me is the important thing. The algorithm, and we'll get a bit more into this hopefully soon, is deterministic. It's just following a bunch of steps. It's just going to give you the result from those steps. It's a human being usually that is telling you these are the steps to follow. It's a human being that's creating that recipe for you. It's a human being that's telling you how to brush your teeth. But the algorithm itself is just those steps, and it's just people following it. Like, it doesn't have a bias towards anything. It is just doing what someone else has told it to do.
I guess, I would say that the other part maybe to that is that basically you're putting data in that algorithm as well. So it's like the algorithm basically provides a perspective about the data set, and you can program that algorithm to see different perspectives based on the data you give it. So if I give the example, maybe this is what you're trying to highlight. I didn't go down to a technical level. I was also trying to make it accessible. So
I get that, but if you stay too high level, it just sounds a bit too abstract and you don't really get a good idea about what's going on.
So maybe what it is let's say it's about the decision making, I guess, that you're trying to highlight here, is the algorithm doesn't make a decision that it's not programmed to do. So we go back to, here's the algorithm that has a deterministic output, right? Now, when you apply it to a video...
Sorry, do you want to explain what deterministic is, just in case there's someone watching that isn't 100% sure?
The outcome is predictable, right? So, or at least predictable to a certain level of error. So what it means is if I put an algorithm on YouTube and I have a data set of your demographics and your prior history, the algorithm determines how to take that information and provide a perspective about who you are in order to present you a video. Now, the way in which I program that algorithm to see a perspective is up to me. So it's really good that we've got two inputs. If I just want to treat you as the general population, I won't look at your history. I will look at you purely from male, a white male, mid-30s, lives in Australia, right? So I might take just the demographic information and provide you with all videos that relate to that demographic information. So that actual algorithm might not necessarily be of value. But then I could actually go the opposite. Let's forget about your demographics. Let's just purely work on your history. So random videos until you build up a history. So now I'm just looking at what it is that you like and what you want to watch. And so I feed that back to you. And so I guess what the algorithm is showing here is it can be programmed to perceive that data from different perspectives, from the perspective of purely just who you are demographically, or from a perspective of purely just your history. Now, I'll give you a good example of why that could be unwanted. So if I look purely at your history, that means more and more I'm just going to feed what you like, and I'm not going to allow you to explore other areas. If I look purely at your demographic, I'm going to allow you to explore other areas that people around your age might like, but I'm not going to basically get the hits that of everything you want. So I guess maybe I'm showing how an algorithm can take a different interpretation on the same data set.
Yes. What we failed to really highlight throughout so far, what we've discussed, is that it's working towards some desired outcome. What is that desired outcome? With the videos, am I serving you videos that will hopefully keep you connected, keep you on this site, keep you watching videos? Am I serving you videos that are going to indoctrinate you, trying to, show you, highlight a perspective and get you to join a certain group, whatever it is? Like, what's important is, what are you trying to achieve using the algorithm? And then the information coming into it is exactly the same. It's just how it filters that information and how it processes that information is going to be dependent on, okay, what is it I'm trying to get out of you? So if you are on a video streaming platform and their genuine intention is just to keep you on that platform and keep you engaged, then the algorithm is based on whatever will keep you engaged. So if you dislike the videos that are keeping you attached to that are keeping you watching, that has nothing to do with the algorithm. That has nothing to do with the person who programmed the algorithm. That has everything to do with you still engaging with that platform, because it's just trying to keep you engaged. So it's going to give you whatever you feed it.
I guess that's the argument for having open source code, isn't it, really? And I know we're going into code here, but the whole point of having an open source code, it's almost like an open recipe. So when I go to the shops and I buy some food that's pre-packaged or something, it's not an apple, it tells me what ingredients are in it. It roughly tells me the amount of ingredients in it, right? So at least there I've got some view of what this item that I would never normally know what's actually in it. So if I buy, a cookie, I don't know what's in the cookie unless I'm told through the ingredients. So algorithm is kind of the same. So with like YouTube and all the rest of it, I think there would be some value that the user understands what the algorithm and why it's searching a certain way, because then you can actually use that to your advantage. You can say, okay, the algorithm's looking for things that I like. Therefore, that's fine. That's what I want. But I'm aware now that it's only going to serve up things that I want it to, that I look at. And so I need to force myself to explore if I want an open mind, because this algorithm's going to close my mind. It's going to try and look at what I like and reinforce that so that I get more views. So if I knew that about when I did a search term, if I knew that when I put in algorithm, right, it's going to throw me people that I like, I might actually go down the list and have a look at other, down towards the end of the list, because I know, okay, there might be a more popular one out here, but it's not someone I normally follow. So I guess understanding, it's probably interesting point. It's the algorithm is built so you don't necessarily have to understand all its inner workings, particularly if it's built by someone else. Well, when it's built by someone else, if it's built by you, you want to know its individual workings. If it's built by someone else, the advantage is they've done all the hard work, you follow the process and you get the desired outcome. But then there is a level of danger or risk with that, because you don't understand how it works. So while you might get a desired outcome, you might not necessarily understand why it got to that outcome, and that could be a little bit detrimental to yourself.
I really like that you made that point, that it is actually it would be very beneficial to understand what the algorithm is trying to do, because it helps you understand. Like if it consistently serves you cat videos and you're like, why is this serving me cat videos? And then you look at it and you say, this is just serving you stuff that you look at. Then it's like, oh, it's on me. It's because I was the one searching for cat videos. It wasn't because they were trying to push me towards that. So yeah, it allows you to see things. And then it's like, if you're seeing stuff that is getting you angry, it's making you upset, and you realize that the reason it is doing that, or the intent of the algorithm, is that to keep you engaged, then you can reflect on that yourself and be like, oh, I'm the one who's choosing to get outraged. I'm the one who's choosing to watch videos that are getting me irate. It's, I have control over that. So you can then use that to your advantage. You can use the algorithm to your advantage, because like it's showing me things that to keep me engaged. Okay, well, I want things to keep me engaged that are beneficial for me. So you start looking at things that are beneficial for you. Maybe you look up exercise videos. Maybe you look up healthy diet. Maybe you look up all these things that are to help improve yourself. And then it's just going to keep feeding you that. So it's like it's a beneficial spiral instead of like a negative spiral. It's a positive beneficial spiral at that point.
Yeah, that's an interesting one, like a motivating cycle, I guess. By forcing yourself to look at exercise videos and getting that in. Look, it does. I mean, I have no understanding about psychology, but I would suggest that yes, interacting with these platforms definitely changes psyche at some level. And so having an understanding of how that's changed is important for the individual users. So to me, it would be really interesting to see, and whether this should be their responsibility. So like YouTube, you can imagine the world might be a little bit different if they had educated their users throughout the process of building their algorithms. So they might not necessarily have needed to take any information or feedback on, but just exposing how they do that system, people will then have a better understanding of how they should interact with it, and the platform might have built a better platform in the long run. But because those algorithms are hidden from the user and the user doesn't necessarily understand what's actually happening, then they might interact with that platform not understanding the unintended consequences that are occurring. So people, the classic case is what do they call it? The bubble, the social media bubble, or whatever they call the
echo chamber
kind of thing. So people started to realize an echo chamber because they realized, they took some time and thought, oh, okay, so if the algorithm keeps feeding back up what I like, and I keep watching these 5 different people, I'm only going to get their perspective. And so while I see the internet as this broad way of getting general information across the globe, what this platform's actually doing is it's only giving me the perspective of 5 people. And so therefore things might seem more exaggerated than actually what they are. So you can imagine someone that's a person that thinks about flat earth, right? If they continually go and look at videos that talk about the science of flat earth, but they do that with search terms such as, why is the earth flat? How come the earth is flat? Or they prompt a question which basically means that they're looking for any evidence for the earth is flat, then they're going to get that evidence. And they're going to get it from these different places, but they think that that's the world of science to them. And so because their results in their search term is not bringing up a wider set of samples, then that creates that echo chamber, I guess. And if they understood, they had a little bit of understanding about that, even to the point, I mean, if you think about it, here are the flat earth videos. There's 100,000 of them, and then, I don't know, maybe you could categorize them in certain ways or something like that. But I think just understanding what an algorithm does, particularly on those kind of platforms, is beneficial to the user to allow them to make actual decisions.
I think we struggle to understand that kind of scale from a human perspective. Like you said, even if there's 100,000 flat earth videos, what if there's 100 million round earth videos? Like, we don't see that. We just see 2 or 3 flat earth ones and we say, oh, okay, it must be a flat earth. But we don't see the other 100 million, like the 100 to 1. I don't know what the odds are. I think it's different, but whatever. there's 100 to 1 saying that it's a certain way, but we're only seeing that one. And so because we have 2 or 3 absolute examples, we think that that's the truth because it's some kind of limitation to us. Like I always think about this in terms of numbers and specifically cryptography, thinking that, okay, 256-bit cryptography, I'm like, surely a computer can figure that out. Like we can't even conceptualize how big a number that is. You know, we have to do all these things. Like certain things you can look at and you can say, that's roughly about right. Yeah, that'll fit, whatever. But I can't even imagine a number that big to understand that, no, there is the chance of collision. Like there's 8 billion people roughly on Earth. Even if every single one of them had their own account, the odds of a collision are so tiny that, you know, that it's not even worth worrying about it. Like, yeah, so I think there's a big problem with that with specifically in terms of like the echo chamber thing, is that we don't have a good grasp of scale, and we've expanded scale from, it used to be a household, it used to be a village, it used to be a state or whatever, and then now we're going global, and we just don't have the intuition to understand things at that scale.
Yeah, you're right. I mean, it's hard to normalize certain information. So, you know, if you go back to what you were saying there, if you had a town or a village, let's say you had 100 people in it, then the likelihood of someone maybe not believing that the Earth is round might be 1 out of 100. So then it's obvious to you where the consensus lies. But if I go onto YouTube and I find 5 or 10 people that have got 10 million subscribers or something, and I get consensus across those 5 or 10 people, then in the concept of a village, that's a big portion of, that's 5 or 10% of the people in the village. And a lot of people are listening to these people in the village. It seems, it appears. Because, yeah, I would agree about that scale thing. I think that we don't have a good grasp of what it actually means. I don't think even you could picture what 1 million people would look like. I mean, even just thinking about the MCG at 100,000 people, it's quite a hard thing to conceptualize. And when you start to broaden it out more like that, you start to realize how chaotic or how varied people's views are, and that technology like this starts to extreme certain people, makes them a bit extreme because their little group, which would normally be a group in a village, is now made up of, you know, one individual here across the planet, and they're pulling those people together at vast geographical distances. In the past, you would never even talk to these people. They're pulling them together to get a consensus on particular information. So, yeah, you're right. Scale, even just the geographical scale, understanding that is something that is almost void on the internet. It's allowed us to connect, remove the geographical divide in these kind of situations, I think.
I think it's important for us as a species to start, because we are keep growing and keep becoming more connected to, we've operated at an absolute level for a long time. Like 2 people agreeing on something to us was okay. Like you said, 2 out of 100, you know, you can easily say, okay, there's a overwhelming majority that believe differently. So we need to kind of stop looking at it from an absolute perspective where, for example, with flat earth, we find 5 people that agree with us. That means that it must be true, and look at from a percentage, or is it nominal? Is that what I'm thinking? Perspective where, okay, as a fraction of the total amount of people, how many actually believe this? Is it 1%? Is it less than 1%? Is it 5%? There's got to be some certain threshold where it's like, okay, 80% of people sampled think it's this way, so consensus is 80%. It's more likely this and that. But then, like we were saying in our other episode, I can't remember which one, just because 80% believe it's some way, it might not actually be that way.
Yeah, that's right. I guess, consensus is a really interesting thing. I've been thinking about it a lot, actually. And after the podcast we did about facts, and how critical it is in our decision making on a day-to-day basis to understand what consensus actually means. And so, yeah, understanding that consensus is usually your best bet. but it's not foolproof. Like you said, just because there's consensus around a topic doesn't mean, there was consensus that the sun revolved around the earth, doesn't mean that it actually was the case. But at that point in time, I guess it was the best bet that people knew with the knowledge they had at hand. And so, these videos, the ability to find consensus on the information that you're consuming is very, very difficult. It's a very big problem, actually, the more I think about it, because there's no real indication of the level of consensus of information on any of these platforms. So it allows anyone to be able to make a statement, and it's almost like entertainment actually I find has an impact on consuming information, because I think for humans, if they find something entertaining, they want to believe in it, which is also a challenge. So I don't have an opinion on aliens. I'm sure they're out there, but
Well, you do then. You do have an opinion. Well, you're confident they're out there.
Yeah, I do have an opinion. But I guess, strong opinion, should I say. Where was I going with the alien conversation?
Sorry.
I threw it off. No, that's all right.
Sorry about that. The other thing I wanted to say about like these kind of platforms is the even worse part is that they're trying to obscure the consensus by hiding things like the like/dislike bar, seeing the amount of people who like/dislike something. Because, like you said, if consensus is as close to truth that we have, when they have something that suggests that, they put out a propaganda video and they see that there's overwhelming dislikes, they want to hide that because they want to actually promote this thing and suggest that it is true. Whereas if they let the consensus actually show and shine through, then it will be the other way around.
Yeah, it's really interesting. I mean, consensus is also manipulated quite significantly. So, like all the bots that bot users or all the rest of it, that's what they're trying to do, aren't they? They're trying to push consensus in a particular direction in order for you to believe in a particular piece of information. And so not having the level of exposure of what what's actually happening is doomed for problems. It comes back to the old transparency, honesty. Transparency is almost the best policy. So, if they're transparent about, these are the amount of bots, I think people would be understand the level of consensus of the information they're being shared, I guess.
There's probably a conversation there about marketing and how, if you get enough people liking it, or, bots that like it, that suggest that people like it, that's how you promote something and suggest that it is better than it actually is, or, get a buzz around it. I want to assert something here, Mick, and then we'll talk about this for a little bit to finish it off, because we had a little bit of a different of opinion, and I brought it up earlier. I want to assert that algorithms are deterministic, no matter how complex they are. And what I mean by that is it's pretty easy to follow a simple algorithm, like a sorting algorithm. Any human, you give them a sorting algorithm, you give them a set of 5 different numbers, they can follow that algorithm and sort out those numbers, right? But you get up to the level of like a machine learning, artificial intelligence, and it's very difficult for us to see, okay, given this input, how will the system respond to that, and what will the output be? This goes to a much deeper philosophical discussion about whether we have free will or where everything is determined. I would assert that if reality is, there are a set of rules that underpin reality that suggest how objects interact with one another, then everything is deterministic. Now, whether we can actually understand that and whether we can work it out, that's a completely different discussion. Like, I would say that as humans, we can't figure that out. We don't have the computing power to actually figure out how things will turn out. But if you did, you could see at any point in time the state of the universe. But let's stick to just algorithms for now. I would suggest that even if they are super complex, even if they are taking inputs, even if they are updating themselves based off of feedback, they are still deterministic as long as you have all the necessary information going into the system and how it runs.
Yeah, so I think when we were briefly describing this, I think the main difference was basically who is it deterministic by? So is it deterministic by us? Or in your case, it's deterministic by who? Is it reality in itself? So is deterministic in your system, who's it deterministic to? Is it, yeah, that's where I think we had a bit of a misalignment.
I think we actually agree on this point, but I think I don't necessarily highlight it when I talk about this kind of stuff, because to me it's like, yes, some being out there that has supreme knowledge or whatever has an understanding of reality far greater than reality itself, could figure these things out. But I don't think from a human perspective that we could say that we could determine how the outcome of every event. And I do think that there are algorithms out there that human beings themselves, we don't have enough computing power to understand how it will respond. And when you get to the level of machine learning, when you get to the level of artificial and general intelligence, when you get to those kind of levels, yeah, I don't think from a human perspective that it is deterministic. I don't know what the opposite is, indeterminate. I think we were trying to figure this out before. It is indeterminate. We are unable to figure out what the output would be from an input when it gets to a complex enough point.
Yes. So it's either in or undeterministic, meaning that the output is not predictable, or even the input's not predictable. So, if I think about robotics, that's what it's trying to do. It either works in a deterministic environment, that would be in a factory, basically taking a bottle from one conveyor belt to another. Its task is well known, its output's well known. An undeterministic robot would be one that actually walked around the environment and made decisions based on the environment in that real time, and wasn't programmed to necessarily do individual low-level tasks. There might be a high-level task, and there might be different ways in which it can undertake that task. So I guess with the AI stuff, maybe one thing I would say is that there is a learning algorithm. The learning algorithm is well known. So we know what algorithm to use to set a system up for learning. But the knowledge it gains from that learning process is undeterministic, or it's as undeterministic, maybe not to the same level, but it's similar undeterministic as in a child learning something. So I can have a child that might watch a video or a movie, or might watch a series of videos and movies. What it takes from that series of videos and movies might be different from the next kid. They're basically the same system. They're giving the same input, but based on their prior experience, they might have a different outcome. And so that's what the machine learning, the process of learning is an algorithm, just like I could follow a process in order to learn how to paint or something. But the way I paint after I've learned how to paint is undeterministic. It's going to be based on a whole lot of experience, I guess. So, yeah, so I'd like to sort of separate the learning algorithm away from what is actually learned and applied. So normally in AI, you train a system, you basically mark its inputs. So you give it a whole series of images that are described. So if I to teach it how to recognize cats, I'll give it a whole lot of animal videos, and I would write where the cats are. And I would say that's the desired outcome for these images, and the other images I want to be rejected. And I would give them a big series. And then at the end of that learning algorithm, I now have what they call the trained system. That trained system I put out there in the wild, and I hope that when it brings in the input, it describes the output the way I want it. And generally, you can never get to 100%. You can get to a level of in the 90s, sort of low to high 90s. And so it's not always a desired outcome that system will come with, and you don't necessarily know why it's come to the determination. if you try to fill out that last percentage, there's only a certain amount of parameters you can change in the learning process. But once it's learnt, you can't really change the system. You don't even know which levers to move in order for you to refine that. You just go back to another training set or a bigger training set and redefine the learning process.
There was a lot there.
Mm.
Even like you said, you can never get it to 100%. One thing I want to highlight there is it's similar with human beings. Like we think we're infallible, but you ask 1,000 people out of, can they pick the cat out of this image? You might get one or two that's like, no, I can't. Whereas it'll be the same for a computer. So it's like if you're ever trying to do something to a level of 100% certainty, you're never going to get there. There's always some level of confidence there. It's like, okay, past 90%, that's as good as any human being's going to do it. That'll work for us. Like it's still a better system than we currently have because it's a better likelihood that it's going to get the desired outcome. A couple other things I wanted to pick up on that you said that, yeah, there's a lot of ways you could break this down and a lot of ways that it varies. So you can look at the input itself, the inputs going into the process, the system, the algorithm, whatever you want to call it. They could be known or unknown. So if, like you say, if you put it out in the wild, maybe you don't know what the inputs are that are going to come into it. Whereas if it's in a factory, you can actually feed it the desired inputs and be able to tell what the output is. Same with the process. It's you can either hard code it. So the machine learning one, like you said, it updates itself. So it's after the first iterations, like I have no idea what it's going to do now. Whereas something where it's like a fixed set of steps, like a normal algorithm as we would think in a computer system, maybe it's a filtering algorithm, like an image, like blurring an image. It's a fixed set of steps. It isn't changing dependent on what the inputs are. It's not getting any feedback and updating. So even the process itself is either you can determine what it's going to do or it's unpredictable. So yeah, there's a lot going on. The only thing can we agree on that technically it is deterministic, but practically it's indeterministic. So technically, if you had the computing power to work things out, you could say exactly what the outcome would be. But in a practical sense, from a human perspective, that's impossible.
Yeah, I think I'm happy with that. Because to me, I see it as deterministic as a human. So, and that was the question I was going to ask you after that. So I think that basically explains the same thing. So as deterministic as you are is as deterministic as some of the AI stuff is. And so, yeah, if I had the computing power and all the effort in the world, I might be able to figure out you from a biological level. But I would say, yeah, it's quite impractical to do.
Yeah. This is a larger point that I want to kind of find better ways to explain it, that there are a lot of things when we get into disagreements, it comes down to technical versus practical, like the whole free will versus determinism debate. You could make a technical case that everything is determined, but from a practical standpoint, is it? If we can't actually understand all the steps, all the interactions that are going on between everything, then is it deterministic to us? Like you were saying, and like you highlighted, it depends on your perspective. Where are you looking at it from?
Yeah. So for instance, an algorithm, the less deterministic it is, the less value it becomes. Because the point of using an algorithm is to get a desired outcome. So that's what I would say about that balance. Yeah.
That's a very good point. And I think that's a good way to leave it. So just to repeat again, like you say it again, because you said it, you summed it up really well there.
Yeah. So I was going to say, if the more the algorithm becomes undeterministic, its results are less and less predictable, the less valuable the algorithm. Because the whole point of an algorithm is to get a desired outcome.
Yeah. Beautifully done. So once again, it's a step-by-step process trying to accomplish some desired outcome. If the steps become obscure and you can no longer guarantee the outcome, then it's a less desirable algorithm. Happy with that?
That sounds good.
All right. Anything else you want to leave us with?
No. And I think that point actually highlights why we need to be careful with artificial intelligence, I would say. because while we can get something to do something, it's probably a little worrying if we don't know how it got there.
Very good. Very good warning there. All right. My supplemental song suggestion for today, it's a bit on the nose, but I couldn't find any other song that kind of matched this theme. The song is Childish Gambino, Algorhythm. And then my quote for today, and this was related to something else, but it kind of fits as well. Get the structure right and the function will follow, by Linus Pauling. So thank you for joining us for this discussion. If you have any thoughts about the topic we just discussed, we'd love to hear them. As always, be well.